Hello everyone, welcome to our channel. Today we are going to talk about the penstock. Here we have shown a penstock in a cross section. This is the pipe, and then this one is its diameter, and this pipe is supported by a saddle support from the ground level. And this is the L section of the penstock. This one is the penstock, where this one is the anchor block holding the penstock pipe, and this is the saddle support for the support of penstock pipe. Now let's talk more about the penstock. Penstock is a pipe which conveys water from source tank to forebay to the turbine. It is designed to carry water to the turbine with the latest possible loss of head consistent with the overall economy of the project. Where the penstock are pressurized water conduit which conveys water to the turbine from the water surface that might be either short chamber device or reservoir or the foreways. Now let's know about the penstock installation types. Penstock are classified into different types depending on their general features, such as the one is exposed penstock, and another one is liner, and the third one is buried penstock. Now let's know more about the exposed penstock. Exposed penstocks are usually fabricated from steels, plastics, wood step pipes. This can be located above the ground or in the non-encased tunnel and are usually supported on either steel or concrete support systems. Main advantage of exposed penstock penstock are easy in inspection, of fault and maintenance, economic in rocky terrain, and the third stability ensured with anchor. Whereas the disadvantages are direct exposure of weather effect, so there may be the chance of weathering, wear and tear. The next one is development of longitudinal stress on account of supports and anchors. So there may be the requirement of expansion joints and manholes and etc. The expansion joint are that part that are placed in penstock for the expansion and contraction due to the weather condition. The next one is steel tunnel liner. In the steel tunnel liner, these are located in a tunnel and fully encased in concrete in a portion of a dam. This type of installation selected should be reflect the cost-effective penstock system, which should be consider the technical, environmental, economic, and construction friendly factors. And the third one is buried penstock. The buried penstocks are usually fabricated from steel, concrete, penstock, or fiberglass. They can be either partially or fully buried inside the soil. The advantage and disadvantage of the buried penstocks are: as an advantage, their conservation of natural landscape, protection from the protection from landslides, storms are the man-made violence, protection of pipes against temperature fluctuation with the help of small overburden soil cover is possible. Continuity of support given by soil to the system becomes strong, and they are more suitable in context of weather, landslide, and any unethical behavior from any people, etc. Whereas from the disadvantage viewpoints, it is difficulty in inspection of faults, as well as inspection and difficulty in maintenance, as well as the possibility of slides in steep slopes. They may not be stable in steep slopes. Now let's know more about the penstock alignment. To determine the most economical alignment of a pipeline, the designer must investigate the site and make various layouts on topographic map. When making the layouts, the penstock should be located on stable foundation sites such as long ridge that has been cut into the mountainside, avoiding of troublesome sites such as underground watercourse, landfill, fault zones of potential slides area is quite important. Selection of the penstock alignment at sites should be based on survey and sourcing. Survey location, minimum number of bends, space for powerhouse, stability of penstock alignment, ground slope, etc. Now let's talk about the penstock pipe materials. The penstock pipe materials are mild steel and SDP, and sometimes there may be rigid. The factors that have to be considered before deciding the materials are weather condition of the site, transportation and its relative cost along with availability at the site, and the next one is design pressure that can resist by the penstock or the selected penstock materials. And another factors that to be considered is method of fabrication of the selected materials and with the fabrication loss in every fabricated joint. Next factors is accessibility of the site, and another is design life and maintenance process. The selected material shall have the proper design life along with the maintenance process, as well as the weight and composition of the material is also the necessary factors that take place during the selection of the penstock pipes. Now let's talk about the design consideration of penstock. The design of safe and cost-effective penstock system requires the consideration of technical, environmental, economical, and constructability factors. Generally, it depends upon the developer's requirement. Site specific condition and site specific study. In the developers or designer requirement, the perfect material and design type shall be required. The operation requirement, social, legal applications or issue are to be the major boundary line for the consideration of the penstock on site-specific condition. These are also equally important due to environmental restrictions, limitation on size and weight, geological restrictions, hydrologic considerations and limitations to the penstock physical layout. Points that must be considered for site-specific requirements are land ownership or right of way of the penstock alignment, and terrain configuration of the sites, environmental resistance including the aesthetics, fish, wildlife and natural habitats, etc. And the next one is site hydrology and geology along with the soil type of the site. Another consideration for the design consideration of penstock for site specification. And another one is applicable of codes and mandatory requirements or the bylaws of the particular sites. Now let's talk about the stresses on the pipes. The stresses developed in penstock pipes are longitudinal stresses and hoop stresses. The hoop stresses can also be the circumferential stress. The longitudinal stresses stress sigma L can be given as the PD is divided by 40, and the hoop stress can be given as sigma C equals PD by 40. A hoop stress is greater than the longitudinal stress, whereas the hoop stress is used for the design of penstock pipe. The allowable stress and the factor of safety to be adopted depend upon the yield point stress and ultimate tensile strength of the steel, loading condition and location where this pipes is to be provided. Now let's talk about the thickness of the penstock. For the internal pressure, the pipe cell thickness can be given with the formula thickness T equals PD is divided by 2 sigma A efficiency plus, where T equals thickness of pipe where P equals internal pressure R equals sigma equals efficiency equals welding joint corrosion of allowance. Whereas as per the ASME code, the formula for the thickness is given as T equals PR is divided by sigma AJ minus 0.6 PA plus 0.15, where PA equals pressure whereas the minimum plate thickness of the pipe is to be calculated considering handling and transportation factors for the case where calculated thickness can be calculated using the relation of internal pressure is very small, where T for this, for T min equals D is divided 288 and another is T min equals D plus 200 is divided by 400. This one is as per Pacific gas and electrics formula, whereas this is as per Bureau of Reclamation formula, where T is the thickness and D is the internal diameter. Among these two values, the greater value will be adapted. After this, we will talk about the head loss in penstock pipe or losses in penstock pipe. Total head loss in a pipe is a sum of major losses and minor losses. The major losses is frictional losses in pipe and minor losses are due to the valve, gate, joint, inlet and outlet structures, bend, etc. The calculated first we'll calculate the velocity in as 4Q is divided by pi d square, where Q is discharge, V equals velocity and D equals internal diameter of pipe. After this, the total head loss equals wall loss plus turbulence loss From this, first determine the roughness value K in mm and then use the Modi chart to find the corresponding friction factor F for the selected pipe materials, diameter and the design flow. The wall loss can be calculated as H wall loss equals FLV square is divided by 2GD, or one loss, or FLV square is divided by 12T power 5, whereas the H turbulence can be calculated as V square is divided by 2GD plus K entrance plus K bend plus K contraction plus K valve, where K is the head loss coefficients at entrance, bend, contraction or expansion and the valve. After this, we will go to the economic diameter of the penstock. Under average condition and present day price, the most suitable diameter of pipeline is frequently one which gives the maximum water supply of approximately 5 meter per second, or that can be varies from 2.5 to 3.5 meters per second. As the pressure head or the cost of the pipes per ton increases, it is economical to reduce the diameter of pipeline. Similarly, as the load factor on the station increases, the diameter should be increased. For a particular station, the only variable is the pressure head, which increases as the pipe runs downhill towards the station. Based on above all this, the equation for the economical diameter can be D equals 5 is divided by equation is for the upper portion where thickness of pipe is determined by minimum thickness, and for the thickness of pipe determined by designing water pressure can be given as D equals 5 into 70. So for this time we end up the video up to this much. We will come again with one new video. Till then, keep on watching our channel and don't forget to subscribe us. Thank you.